Now that you've done the reading, I'd like to walk you through a brief slideshow that I think will help explain some of the topics that we covered when we learned about exposures. What we're going to cover here in the slideshow is shutter speed, f-stops, and depth of field. Before we can talk about all these, I'd like to talk about the inside of your camera. This is your sensor. When I refer to light reaching the inside of your camera, what I'm really saying is light reaches the sensor. The sensor functions the way film used to function in older cameras. When you make an image exposure, it is the sensor that records the image. All of us in this course are using different cameras, so when I use terminology, it's universal, such as ISO, f-stop, and aperture. They apply to all cameras no matter what brand. So I suggest that we find your manual to your camera and you follow along, making sure that you understand where to locate various dials and knobs on your camera versus the models that I'm going to be using in the tutorials. Let's get started. The first thing you're going to need to understand is f-stops. F-stops is essentially the hole in your lens. It allows more light to come in when the hole is bigger and less when the hole is smaller. We talk about f-stops in terms of numbers: f2.8, f4, f5.6, f8, f11, f16, f22. Depending on the make and model of your camera, you may have more or less of these f-stop numbers, but you will essentially have the same collection. The lower the number of the f-stop, the larger the aperture opening, and this is because f-stops are fractions. So f22, while it's the highest number, is the smallest hole, whereas f2.8, the smallest number, is the largest hole, and so on and so forth, f4 being smaller than f5.6, and 5.6 being smaller than f8. So what you're looking at here is essentially that f-stops, fractions, work in this way. The lower the number of the f-stop equals a larger aperture opening. The larger the aperture opening, the more light reaches the film. The more light reaches the film, the more exposed the film is. A small chart down here shows us how in various lighting conditions you might want to set your camera. We are not going to use these f-stop numbers religiously. We are going to look at our light meter, which we'll learn about more in this lesson, but this is a good rule of thumb. If you have an extremely sunny day, you are going to have an f16 or higher f-stop. That is because on a very bright day, you would want a small hole not allowing as much light in. Whereas on a deeply overcast day where there's little light, you would want an f5.6, which while it is a small number, is a large hole which will allow more light to come in. This will become more clear as we do our lesson this evening for our assignment. It is essentially the reverse. The larger the number, the smaller the hole. What we have here is an example of overexposed and underexposed. As I said, if less light reaches the camera sensor, you have a underexposed image. So on the bottom here, where the image is darker, you will see that not enough light reached the sensor chip. The same image on the top is overexposed, meaning too much light entered the sensor chip. This slide is an example of how the same exposure of the same image changes using different f-stops. From left to right, we have the small f-stop of 2.8 to the larger f-stop of f22. You will notice that the first image of 2.8, which would be the larger hole opening in your aperture, is the brightest. That's because the larger hole let in the most amount of light. Whereas if you go through the images, you will find f22, which is the smallest hole in your aperture, allows the least amount of light in, and therefore is the darkest image. All these photographs were taken at a 60th of a second in shutter speed, which means it froze time. We're going to talk more about shutter speeds now and their relationships to f-stops. Shutter speeds are also fractions. For this course, the majority of our photographs will be taken at a 60th of a second or faster. The reason for this is because a 60th of a second freezes time. The longer the shutter is open, the more light reaches the film. The more light reaches the film, the more exposed the negative becomes. If you're in a darker location, the darker location of the photograph being taken, the longer the shutter needs to be open, allowing more light in. The longer the shutter is open, movement will be visible, equaling blurry photographs. So with shutter speed, you really need to pay attention to what you're doing, making sure that you're not going slower than a 60th of a second, unless that's the goal to show motion. This photograph here is of a motorcyclist. He is definitely moving and definitely at an angle, but his motion is frozen because we took a picture at a 60th of a second. Here we have another photograph of the Los Angeles highway where you can see the streaks of the headlights because it's taken slower than a 60th of a second, it's taken at a 30th. This allows movement to be visible because the shutter was open long enough for the cars to drive through the picture frame before the shutter closed. Now that we understand what shutter speeds and f-stops are, the question is, how do these two things work together to give us professional exposures? Every time you take an image, you need to set your shutter speed and your f-stop. They work together. They're reciprocal, meaning there's a give and take relationship between the two. The chart below shows several clusters of f-stop shutter speed relationships. Each one of these clusters, if it were to be a true photograph, if you would set your cameras to this f-stop and to these shutters, would result in the same amount of light reaching the sensor, meaning you would have a photograph with exactly the same light exposure no matter which cluster you used here. f16 and 1/80th of a second would give you the same light exposure as f11 at 1/15th of a shutter speed, whereas f8 1/30th of a shutter speed would also give you the same light exposure, and so on throughout the chart. This is because they work together. If the hole is small, you need more time to pass to allow light in. So f16, why is very small aperture opening, is open for 1/8th of a second, versus the last cluster in the chart, f2, which is a very large hole, is only open for 1/500th of a second, a short period of shutter speed, equaling the same amount of light reaching the sensor. So the question is, if you can manipulate either your f-stop or your shutter speed to make an exposure, why would you care and what would the difference be? When would you choose to manipulate your f-stop to make it larger or your shutter speed to make it slower? Well, this is where we finally get into the visuals of photography. If you have a shutter speed that is long, 1/30th of a second or longer, you can show motion. Sometimes this is a problem, like blur, but sometimes this is an artistic decision. This photograph on the right-hand side shows a long exposure of 1/30th of a second, which shows the water in motion. However, because the shutter speed was open so long, what I had to do is make my f-stop high at f22, a very small aperture opening allowing less light in. That's because the slow shutter speed of 1/30th of a second allowed a lot of light in. But I wanted the slow shutter speed because I wanted to show the motion of the water. Therefore, I was forced to go back to my f-stops and make it a very small aperture opening at f22. This allowed less light to come into the camera so I can get a proper exposure. Another reason you might choose to manipulate your shutter over your f-stop or your f-stop over your shutter is something called depth of field. Depth of field is a very important concept in photography. It allows us to make more complex compositions and really separates amateurs from professionals. Understanding depth of field allows you to manipulate the viewer, to improve the photograph, and to draw attention to specific details in an image, as opposed to point and shoots where you have no control over the depth of field of your image. Very simply, depth of field refers to the range of distance that appears sharp in a photograph. This is a completely simplistic summary of the term depth of field, and I do expect you to go back into your reading and think about this further, but I think this definition will be enough for us to go further into the slideshow. So depth of field is spoken about in two ways: a shallow depth of field and a deep depth of field. A shallow depth of field on the left-hand side shows us an image where only one of the picture planes is in focus, the yellow building, whereas the foreground and the background buildings are out of focus. This is because the larger the aperture opening, the less the picture area comes into focus. So an f2.8, which is a very large aperture opening, would allow only one of the foreground, middle ground, or background to be in focus. In this case, it's the middle ground, the yellow building. The same photograph taken on the right-hand side has a deep depth of field. This was shot at f16. An f16, which is a smaller aperture opening, allows more of the picture to become into focus. The background buildings, the middle ground buildings, and the foreground buildings are all crisp and sharp. These are the two different ways that depth of field is used: shallow and deep. A shallow depth of field, again, comes from a small f-stop, such as a 2.8, whereas a deep depth of field comes from a large f-stop, such as an f16 or an f22. The smaller the hole, the more in focus. The larger the hole, the less in focus. In order to have a better understanding of depth of field, a side view of a photograph will give us more clarity. What you have here is your camera on a tripod, your baseball, which is in the foreground of our photograph. The 3 feet between the baseball and the baseball player is considered our middle ground, and then finally our background is Roger Clemens. If this image was a deep depth of field, what you would have is both the baseball and Roger Clemens in focus. But since it's a shallow depth of field, only one of our picture planes could be in focus, in which case the foreground, the baseball, is in focus. The middle ground, the field, and the background, Roger Clemens, is not. Looking at another photograph to explain depth of field, these are our gnomes. In the top photograph, which is a shallow depth of field, only our middle ground gnome is in focus. Our foreground and our background gnome are out of focus. On the bottom image, we have a deep depth of field where all 3 of our gnomes, our foreground, our middle ground, and our background gnome, are all in focus. An assignment tip: when you do your homework, you're going to be asked to shoot a set of depth of field. A set of depth of field is exactly this. The top photograph shows us a shallow depth of field where only one of the picture planes, in this case the middle ground gnome, is in focus, whereas a deep depth of field allows all 3 picture planes, the foreground, middle ground, and background gnome, to be in focus. This is a set. This will be asked for you to do for homework. Finally, before we end this slideshow, I want to show you one tip that will also help you with your homework tonight. Hold the camera with 2 hands. Get a good grip, it avoids shake. You have a lot of things going on. The last thing you need to be worried about is waving your camera all over the place while you're trying to take a crisp, in-focus picture. Alright, that's it for now.